Hello, everyone. So, good afternoon. So, thank you for joining us for today's webinar. So, on basically factory life cycle digitalization. So, basically, today we want to talk about how you can digitalize the entire life cycle of a factory. Let us start with the agenda. So, this is a monthly webinar that we do on various interesting topics. So, do join in for other webinars as well. So, myself, Srinidhi, I head the engineering services department here at Desapex. So, today I would be driving this agenda on introducing Desapex to you guys and then talk about a little bit about factory life cycle digitalization and factory life cycle digitalization and various aspects of digitalization of your factory. Okay, and we shall also discuss about certain challenges and problems which one may get during digitalization as well. So a little bit about Desapex. Desapex is basically an digital engineering company. So we operate in India as well as Europe. So our Indian headquarters is in here in Bangalore, and our European headquarters in Sweden. Basically, we help our customers during design, construction, operation phase, and also renovation stages of any particular built asset. Specifically for digitalization, not just your buildings or your built assets, but we do support with our various digitalization technologies in the uh, digital network that you have seen, whether it could be your industry 4.0 implementation, or you want to have a better visualization using an AR or VR, or you want to survey your entire plant because you want to renovate it. Even surveying is something that we do with various digital technologies, and we also work on technologies like digital twin to integrate any of the processes that you may have. You want to bring them onto a digital twin to develop some analysis so that you can do some modification in your processes. This type of custom consulting is also something that we take care. So, about a little bit more about Desapex. In fact, Desapex became globally the first organization to be certified from BSI for ISO 19650, where it talks about design, construction, and operation digitalization uh, as per ISO 19650 process, where five of our projects got audited and we got this certification. So, whenever we talk about factory life cycle digitalization, since this is such a vast topic, so it is very important that we set up the boundary conditions for our today's discussion and then try to do as much as justice for that topic. Today, when we talk about the factory life cycle, it could be it will start from factory layout design. It could be a green field project, or it could be existing factory which you are renovating, or maybe you have taken over some factory which you want to develop for your organization. So this stage we call it as factory design, layout, and construction. We are discussing about that. And factory operations. When you talk about factory operations, once you complete your commissioning of your factory and all your machineries, you start your production. So at this stage, so we are talking about operation and maintenance stage. And then you want to renovate, because today most of the factories are already filled with capacity, and you want to expand, or you are taken over some existing factories which you want to renovate. For all such activities, how does digitalization work is what would be the major discussion topic, and these are the broad umbrellas under which we want to drive our discussion today. So before we go to the how do we do it, so let us discuss some of the benefits of digitalization. So when we always say this, I think everybody knows today what is the benefit of digitalization, but still it is very important that we understand it to the core and also document it for our particular projects or for the organization. Because in an organization, how much digitalization is one of the key question which need to be answered, and how much we need to spend for that, or the return on investment, which is what the executives need when they are deciding on that. So let us discuss about the digitalization benefits. So one of the digitalization benefits during the design and construction stage could be for visualizing your factory layout before construction. Because buildings could be typical, but factories are always unique and they are supporting a business critical processes. So it is very important that we develop the entire factory layouts in a manner where each stakeholder, whether it be your line manager, whether it be your maintenance team, or whether it could be your mm, people who are actually working on the shop floor, if they visualize the factory the much before the construction starts during the design phase, so then what happens is they can add so much of value into that, so that once it is built, you don't have to worry about, okay, that is not fitting in or this is not working right. And also it reduces the costly errors during construction. See, if you virtually build a factory using various 3D modeling tools, what happens is you have already avoided, it is as good as you virtually building it once, fitting in all your machinery equipment, ensuring that the necessary clearances are there, so that once you hit the site, or once you start the construction on the site, the downtime for you will be very less. Otherwise what happens is you do the traditional layouts on two dimensional drawings, then you go to the site, and then something is not fitting in, or the clearances are not there, or the foundation requirements are not taken care, and then once the machinery comes, it causes the delay of the overall project. Hence your commissioning dates or your operational dates go up, which may not be the most optimal way of doing things. So if we have better planning, if you are also for expansion projects or renovation projects, where let's say you have an existing unit and you want to expand that particular unit to a larger facility, or additional capacity you want to add in the same existing factory. So getting the survey of the existing factory, developing a digital 3D prototype of the entire factory, including the machinery, will give you a better overview on how well you can expand your capacity, and then add more and more, whether it is lines or whether it is conveyor belts. Based on your particular process, you can do that analysis. Then increasing the uptime using digitalization or digital twin. Today what happens is industry 4.0 or digital twins have become buzzwords in our industry. Everybody wants digital twin, but for that digital twin to happen, a data basic structure of data should be ready, so in digital format, for which the basic requirement is a 3D model. So once you have these 3D models and the real time data coming in from your operations, so what happens is you will be able to overlay that information and then understand how your factory is performing, so that you can derive meaningful analysis out of it, and then understand if there are any equipment or if there are any machinery which needs maintenance proactively, so that you do not have to suffer any downtime for that matter. Not just uh, people, not just machinery, People are also very important aspect of digitalization, because what we don't understand is it is not always that digitalization is bad for people because it will take their job. No, it is not necessarily like that. Digitalization helps people to work in a much more productive manner, where they can focus on the important aspects and leave some of the repetitive tasks and the tasks which are hard on the body or not so safe to robots or some of the other tools which can be helpful for them. So in this, what happens is, maybe a body posture of a particular worker, let's say, uh, uh, in a line assembly, so somebody is repetitively getting back pain or some specific illness by working in that line, then what can be done is, somebody can do a posture study and then suggest what is the right way to work on that particular line, because there are certain activities which can potentially harm the worker on the shop floor. So these kind of analysis can actually bring in a lot of productivity and a safer work environment for the worker, and improve the productivity in general for the organization. And today, of course, all large organizations are talking about reducing the carbon footprint, and they want to be more efficient. Of course, in global context, the because of various geopolitical issues, we all know that the energy costs are going up, and all want to invest on new ways of doing things where they'll need less energy for production and reduce their carbon footprint. So unless we are able to measure and identify the machinery or the processes which are consuming a lot of energy, then we will not be able to reduce it. So it is very important that in our digitalization, we also focus a uh, lot of times on sustainability, energy efficiency, and all these kind of things. So let us talk about the design and build stage digitalization, where this is the stage where, let's say, you have identified a plot or identified a site. So you can deploy a HD laser survey for the greenfield projects. So if it is a, let's say, a 50-acre campus, so now you want to start your schematic design from all the way from where would be your actual shop floor to production unit to, let's say, where would be your security, where would be your entry, and where would be your scrap yard. So many aspects are there to figure out how would you do in a 50-acre campus. Traditionally, we have been relying on manual survey data, which comes where the surveyor goes to the site, brings back the information, and gives it to our designers, where they work on the master plan layout of the overall factory. Or today, it could be a drone hovering over 200 feet, 200 meters above the site and getting all the information for you, where that the 3D geometry of the entire site can be extracted, and then your designers can work on the factory plan or a master plan, where they can indicate at a schematic stage where what buildings are going to come up. So by this, what happens is that some of the times we unnecessarily have to excavate to find a lowest point for water draining, or do some waste management or something like that. But what if the site already has a point where you can strategically plan in such a way that it can be utilized? So for all such scenarios, what is required is using a high definition survey with the 3D terrain data coming up from that. You could use a drone, or you could use a laser scanners for that matter, which can bring in that information for your designing team. And then these uh, schematic layouts, So not necessarily that you have to work on a 2D layout and then go for the prototypes which are built out of cardboards or 3D printed for that matter. So today you can schematically plan the entire factory in a 3D model. So using various PLM or BIM tools, where the entire model can be utilized for your visualization. And this visualization need not to be just on a 2D drawing, or it need not to be printed or with a cardboard or something like that. You can use the upcoming or widely used technologies like virtual reality, where you get to see the entire factory layout, and you can also bring in your maybe international counterparts if you are an international company where you need to have consensus from your global team. Or you might bring in some industry expert who is sitting somewhere in another country, who want to see how the layout is coming up. Or it could be an investor who is actually investing on the factory. Or there could be a lot of people within your organization who are experts, who are helping you with the factory layout, but they may not be able to understand the drawings which are developed in a most effective way. So for all these reasons, you can project it in an augmented you can augment the design using some AR tools, where somebody can review the factory layout, or they can wear a VR glass in a controlled environment where they can see, and we can collect their feedback for, so that the layout which is developing has all the necessary information to be able to work efficiently. Once the schematic design is freezed, or even this could be in a detailed design phase as well, we need a budgetary estimate of how much it is going to cost us, which is one of the very important aspects. So what happens is, if you are working on some of the 3D models today, the most technologies like that could be PLM or BIM kind of technologies are capable of giving you the quantities and the bill of materials for your procurement as well. And before you set foot on the ground, or before you start any activities of construction or even excavation, you can understand how much sustainable your design is compared to your previous projects maybe. Or you can benchmark with other factories who are comparable for your own industry, and see how much sustainable your upcoming design is. So the beauty is, you get to do all these kind of things during the design, so that the key executives who are taking care or has a keen interest on sustainability, or a board which is very much making its emphasis on sustainability or its carbon footprint, can understand, have the right data to give their decisions on this matter before we proceeding on to the actual construction per se, right? So then what happens is, because you have a 3D prototype of your entire factory, so what can happen is, you can also bring in some advanced construction practices, so that you can reduce the construction timeline. Otherwise, if you go with the traditional construction practices, then what happens is, the timeline optimization can only happen through either deployment of more resources, which may not be always in favor, and sometimes beyond a certain point you cannot expedite the construction, which becomes a largest risk factor for most most factory completion, or the starting of the production. So that is why it is very important that we use digitalization as a key part even in this stage as well, so that you have a target timeline of, let's say, 7 months or 14 months of opening your factory. So we work backwards and choose a construction practice also, a construction methodology also, or a project management methodology also, which fits into that timeline, rather than realizing it 4 months just before the opening, that, oh no, we need another 6 months to close this, or something like that. So We all are working in an environment where I think people have deadlines, and somebody else have committed the deadlines to somebody else. So it is always a great thing to have some new technologies come in which can substantially reduce the timeline. And you, because you have digitalization as a key dimension in your development phase, so you get to experiment with various construction methods which are newly developed. It could be like a 3D printing, or it could be an engineered building which gets assembled just on your site. All such options are also possible for your usage. Okay, so in this stage, what can happen is not just your drawings. So suppose you have any an existing factory which, let's say, you want to digitalize. So if you have any 2D drawings of that particular layout which are old, or it could be in paper formats as well, so that can be taken up and converted into a factory information model. It could be a 3D representation of your actual factory, where even your existing O&M details, your GA drawings, your machine layouts can be fed into this along with the attribute data of those particular machines to develop a factory model. So in 3D, so where this factory model can then help the development of a new model, where the designers can understand how the old model can be utilized for the new development. Or also during the expansion or innovation stage, it becomes the benchmark for expansion of the other stage. So this can be used for coordination, so where between the services, access is available or not, maintenance space is available or not, all such things can be done. You can take quantities and other informations coming out of these intelligent 3D models, and of course drawings which are pretty much required for your construction phases. So here I want to show one of the video where we are representing how you using your HoloLens can be pretty good, where one of the member can be reviewing the models. Yeah. So another video what I want to show is not necessarily this is just during the design stage. This could be in any stage, where for one of our customer, so they wanted to use the technology of VR for training their people before they actually use the machinery. Because sometimes what happens is the machines are so costly that training physically on the machine itself, for, let's say, if there are 300 people who have to work on that machine, becomes tedious, time consuming, and sometimes costly also if something goes wrong. So that is why using some innovative technology like VR, where you can virtually simulate all the processes what you would do on that particular machine, can actually save time, and it is much more safer and economical, because you don't have to use any real materials. So in this, what we had done for one of the customer is demonstrate how lathe operation can be automated in a virtual simulation environment, where the operator can actually use the lathe machine in the virtual world, and then improve his skills in the physical world. You can also benchmark different operators on how efficient using the machine before they actually go on the site. Or you can also set a minimum benchmark that, okay, any operator who has to actually operate the machine cannot go unless he secures, let's say, 50, a score of 50 or something like that, so which could be very specific to your particular machinery. So during the design and construction phase, how this works is, any machinery which you have set up, okay, So you get to operate it before you do it physically. So here, if you see, so this simulation tool can be as detailed as your machine itself, where you can perform all the simulations on that particular machine in the virtual environment though. So in the interest of the time, I'm just skipping this video. So if you see, all the processes, including the material feed, all those things can be actually digitalized in this. Okay. So here, before I would like to request my colleague Varun to take care of the next section of the presentation, where he will be talking about the other aspects of digitalization. Over to you, Varun.
Yeah, thanks for that introduction, Srinidhi. I think I'll take care of the operation and maintenance stage now. So in the operation and maintenance stage, so what we can do is we can use the same the model, the factory information model uh, during design and construction stage into a digital twin for computer-aided maintenance management, that is the CMMS solution. And also the same model can be used for training, like the video which Srinidhi showed now, for lathe machine training operations. So similar way, it can be used to induct the new employees for safety training, for evacuation planning, or if there is any undesired state training which has to happen in a factory. So usually we cannot do those kind of live trainings because it takes a lot of downtime, and we have to inform the authorities to do that kind of training, and also inform various departments. But by having digital twins, we can have the training on the model, and we can actually train the people for all these kind of hazard or safety related issues. And also the digital twins can be used for energy management, which we will go through in detail. And also we have conducted many other webinars on specific of energy management and digital twins, how we can connect it. And then process twin for manufacturing process optimization. So once we have captured all this data, so we can actually link the shop floor, the all the PLC controllers, the SCADA, and also the manufacturing execution system to an ERP system. So all these databases are actually connected, and then you can create a process twin to see what is that optimization which you can do in your actual production lines. So, and then this is the method which we use for operation and maintenance stage. So where we have lasers, we have a physical factory in place. and we do the particular scanning of a particular application, scanning of that entire factory layout, and then the model is created. I'll also show how the laser scanning can be done and what is the method and process to do that for an existing factory. Say, for example, if you don't have a BIM model or the factory information model, so you can actually create this using laser scanning, and then connect all the various IoT sensors data and PLC SCADA data and asset data of that particular equipment and the user generated data to a twin, digital twin. And then all this kind of asset management, energy management, and building analytics can be done. So this is the method what we use for laser scanning. So we scan first the facility, then do the registration of that point cloud data, and then the modeling is done, and then the RCP or the kind of floor plan layouts are being created for that factory. Whether it can be a machine drawings, it can be a layout which depicts the machines in that particular floor plate. All those kind of drawings, layered drawings can be produced. And this is the video which explains about the process. Yes, this was the video about how we create the scanning, how we create the digital twin using reality capture. And then once that model is created, so either it can be used, the drawings can be used for factory plan optimization, line planning, all those kind of things. And also, so this can be used for asset maintenance management and operation management stage applications. So you can use it for energy management, where all the electricity, heat, gas, or water, and different type of utilities which are used in that particular building can be linked using individual IoT gateways, or we can have a centralized system to actually collect the data from all those sources and connect it to the solution. And then the 3D layout which you have created creates a kind of a map where you can analyze various things. So you can analyze the movement of the people, or you can analyze the movement of your AGVs, or different kind of moving systems which are there. And also you can actually see where there is where there is breakdown happening in that particular layout. You can see that as well. So you can do the based on that, you can do the reactive maintenance, and then preventive maintenance, where you have a 52-week calendar of the entire maintenance plan. And then that maintenance plan is actually linked to the asset. So it is not just a calendar which is there on a standby mode, but you have all the asset linked to it. So that is how we do it. And then this can be used using mobile app or workstations, and then it can be connected into different external systems like other ERP systems, where you can do workplace management, work order management, and different kind of things. So this is the data structuring which we are proposing for thinking factories. So the main thing is that once we have the base layer of all the assets within the factory with respect to utilities, with respect to the process. So those asset digitalization is done, and then on top of that, there are a lot of intelligence layer which has been added, and then you create an IoT customized IoT solution for the factory, and then link it to various data analytics or user related solutions. So this is again the same kind of data structure. So where you have asset use cases where there are a lot of static data which is coming in. So this is very important to understand this diagram here. So when we say data management, there are two types of data which are coming in. There are static data which we have connect using laser scanning, existing CAD drawings or 3D models, asset information, operation manual. So all those things are static data which are there today in documentation, in terms of PDF, scan data, all those things which are discrete data which are available. And then there are dynamic data which are coming from individual IoT sensors, energy meters, PLC SCADA systems, actuator sensors, all those things which are coming in there. And then it goes to the next as a sense making platform. So where we can actually use it for line planning, asset management, energy management, building, analytics, maintenance management. So these are the sense making platforms. And then based on these sense making platforms day to day inputs, so there can be a decision taking triangle which is a machine learning. So today what people talk is that digital twin is a if you have a digital twin, there is 100% autonomous factory. You not to think about it. It's not like that. So we have to create a layer by layer of data. So there are discrete data which are coming in from different type of systems, and then there is a sense making platform, and then on top of that is what we call machine learning or basically, I mean, the broader spectrum of AI. So all those things come on the top of it. So if we don't have the basic layer of data management, so it will only serve a particular use case, a specific use case, but not a holistical use case of running a factory in an optimized manner. So you can have a discrete single line use case, not at the holistic level. So this is what we propose to our clients, and we have been successfully doing it, where we have done the data management, and then the sense making platform has been deployed, and then we are taking it to the decision taking stages. So what are the challenges for creating this digital fabric is that there is a when it comes to the existing infrastructure within the factory, so there is the network which has to be available. So we see there are a lot of factories in very remote conditions where there are no proper internet connection. So we want to do implementation of IoT, we want to have a digital twin, but there is no net internet communications available there. So there is a lot of latency in the communication, and not only the public internet, but there is no any private intranet also. Sometimes we need to propose starting from that, where we have to create a private internet, and then all the communications which has to happen from device to device and device to human interface, there also there are a lot of latencies. So we have to think of certain edge computing mechanism as well to overcome that kind of latency methods. And then if you are planning for an IoT device, I think today, since the 5G network rollout has happened, so there are a lot of options for creating private 5G network for each factories. So that is also one advantage which people can take over with higher bandwidth, with lower latency. And a lot of customization can be done specific to your industry. So if you are a glass manufacturer, or if you are a semiconductor factory, there are a lot of very use case specific or industry specific applications which has to be done. Some components has to be on edge, some components has to be on cloud. So these can be decided very quickly based on the type of network. So that is one thing. And then core process digitalization is not discussed. So if we take individual system digitalization, so although we have to conduct multiple pilots to see what runs best and what is not suitable for the particular factory, but I think we should not have that all or none mindset here. So sometimes when what we see is, if we have not done something of a particular use case, we feel that this is not serving my process or this is not giving ROI. So we have to see ROI in a holistical manner. So if you are doing something with respect to digitalization, we have to see how that will get tailored to the next solution. So how it will go to the sense making platform, how it will go to the decision making platform, because digital twins at the end of the day cannot be again creating a parallel system to BMS or PLC SCADA and human controlling it again. So it has to be if it has to be an autonomous structure, or if it has to be a artificial intelligence or any guided system. So there has to be sufficient amount of data layer or data fabric which has to be created first, and then we have to take it to the sense platform, individual application level platforms, and then take it to the decision making thing. So this is we feel that sometimes it is missing, because we jump to directly to the last step, where we start that do we have certain applications which can immediately give me results. So I think we have to start looking at core process digitalization, right from raw materials coming into the factory to getting it out, and also the utilities factors of it, because factories are the large, energy consumption is happening at a very high level. So we have to understand how those can also add value to your entire process. So these are the challenges which we feel today are there in the market when we are approaching different customers, or when customers are talking to us. So these are the type of challenges which we have come across. So I think that's all for today. And I would like to thank everyone who has joined this session. And if there are any questions or anything specific to your requirement which we should answer it, so please feel free to drop in an email to sales@desapex.com, where we can reach you out and have a one-on-one discussion related to your specific use case. I know that there might be many questions where you might have a specific use case of your factory. So we can discuss that. But if there is anything to know in general, please feel free to ask now, where we will be able to take such questions. Since there are no any questions coming in, so I think we can wrap this session up. Once again, thank you everyone for joining this session and giving your valuable time. So, and please stay connected with us on all the platforms, and we can actually yeah, I think there is one question which has come on. 5G can network can work as LAN also, means data is local. Yes. So yes. So 5G private 5G networks actually work like that. So we can have a 5G network privately installed for your factory, where the data stays in a local server. Yes. So we can deploy like that. The private 5G network we can deploy like that. So there is another question that from a associate, where they have implemented virtual reality recently, but there is issue in terms of network unavailability most of the sites. So yes, so I think that is what we were proposing. So if you are going for virtual reality, I think we have to see how we have to develop the application. So today, what we have done at Desapex is we have developed a custom-made application, VR applications, where it is like a game. So you need not need any internet connection for that. It can be deployed on the local server, not on the cloud. So we can take that instance and deploy in your local server, and each VR can be deployed at local sites. So say, for example, if you have factory at 5 locations, same training VR or a training solution can be implemented at 5 locations individually, locally, not on cloud. So this has been done and successfully. Thank you everyone.